Carbide burrs, those precision rotary tools engineered from tungsten carbide composites, have become essential for bicycle and motorcycle customization, enabling enthusiasts and builders to refine lightweight materials with exacting control, transforming stock components into personalized, high-performance upgrades that enhance ergonomics, aesthetics, and functionality. In the world of cycling and motorcycling, where frames, handlebars, and brackets are often crafted from aluminum alloys, carbon fiber, or titanium to minimize weight while maximizing strength, Carbide burrs, operated at 8,000 to 15,000 RPM on compact rotary tools like Dremels, offer vibration-free abrasion that removes flash, contours edges, and adds custom textures without compromising structural integrity. Their fluted designs, such as cylindrical for broad smoothing or cone-shaped for fine detailing, allow for mods that go beyond factory specs, like ergonomic handlebar shaping for better rider comfort or deburring frame welds for seamless airflow. This customization not only improves ride quality, reducing drag by up to 5% on aerodynamically refined parts, but also personalizes bikes for events like Mason, Ohio's annual cycling showcases or motorcycle rallies, where unique touches stand out. By selecting burrs suited to lightweight materials properties, aluminum's ductility requiring finer cuts to avoid galling, carbon fibers' anisotropy demanding low heat techniques, these tools empower builders to iterate designs safely, blending industrial precision with creative flair. Shaping handlebars exemplifies a popular customization technique where carbide burrs sculpt stock aluminum or titanium bars into ergonomic contours that fit the rider's grip, reducing hand fatigue on long rides while allowing for personalized rises or sweeps that optimize control. For aluminum handlebars, common in entry-level bikes for their 2.7 grams per cubic centimeter density and corrosion resistance, select a flame-shaped burr, 1/4-inch taper, double-cut flutes, to follow the bar's natural curve, its elongated profile enabling gradual material removal, 0.02-inch depth per pass, without flat spots that could cause stress concentrations. Narrate the modification steps. Begin by clamping the handlebar section in a padded vise to secure it firmly, marking the desired contour with a template, e.g., a 10-degree upward sweep for climbing comfort, using a fine tip marker. At 10,000 RPM, engage the burr with light sweeping arcs from the clamp area outward, angling at 30 degrees to feather the top edge for a smooth transition, pausing every 20 seconds to clear aluminum chips with compressed air and check symmetry with calipers. Aim for a 0.5-inch rise over 6 inches without thinning below 1.5 millimeter wall thickness. For titanium upgrades on high-end motorcycles, switch to a finer single-cut oval burr, 3/16-inch head, to blend the drops, its rounded form preventing the alloy's tendency to work harden, increasing hardness from 300 to 400 HV under friction, resulting in a bar that weighs under 300 grams yet withstands 500 Newton-meters torque. Conceptual bike diagram. Envision a side view profile of a bicycle handlebar, left side showing the stock straight bar as a simple line with uniform thickness. Rightward, the flame burst path is arrowed in a curving sweep, depth shading illustrating the contoured rise, light gray for removed material, with cross-sections at key points depicting wall integrity, 1.8 millimeters pre-mod to 1.5 millimeters post, and a rider silhouette overlay highlighting improved wrist angle for reduced strain on century rides. Deburring frames is another key technique, where carbide burrs eliminate weld flash and sharp edges on aluminum or steel tubing, ensuring smooth aerodynamics and safety for custom builds like fat tire bikes or cafe racer motorcycles, preventing snags on clothing or skin during assembly. Lightweight aluminum frames, 6061T6 alloy, yield strength 276 megapascals, benefit from a cylindrical burr, 1/8-inch diameter, double-cut flutes, for its straight-sided efficiency in smoothing long seams, removing 0.01-inch protrusions without overheating the heat-treated material, which could drop strength by 20% above 200 degrees Celsius. Step-by-step narration. disassemble the frame if possible, or mask non-target areas with tape to protect paint. Clamp a tube section in a rotating vise for 360-degree access. Then, at 9,000 RPM, apply the burr in linear passes along the weld bead, 0.005-inch depth, rotating the vise slowly to blend the toe and root evenly. Using short bursts to avoid embedding particles that cause galvanic corrosion in salty road spray. For carbon fiber frames on high-end road bikes, opt for a diamond-coated cone burr, 1/16-inch tip, to delicately feather exposed fibers post-layup. Its fine grit, 400 equivalent, abrading resin without delaminating layers. Interlaminar shear strength, 50 megapascals. Narrating the caution. Test on scrap fiber first, limiting passes to 0.002 inches to preserve the 1.5 to 2.0 gigapascal modulus. The result is a frame weighing under 1 kilogram with raw finishes below 1.6 microns, enhancing laminar flow for 2 to 3% speed gains. Illustrative diagram: a front view of a motorcycle frame tube, pre-de Burr, showing jagged weld beads as irregular spikes. The cylindrical burr's path sweeps horizontally, smoothing to a curved fillet, R equals 0.02 inches, with magnified insets comparing fiber integrity in carbon, intact weave versus frayed, and airflow lines streamlining post-mod, visualizing the MOD's impact on both safety and performance. Customizing brackets and mounts extends Burr applications, where shaping lightweight titanium or aluminum components for accessory integration, like clip-on lights or GPS holders, allows for tailored fits that reduce vibration and weight on bicycles or motorcycles. Titanium, Ti6Al4Fi, density 4.43 grams per cubic centimeter, requires a ball-nosed Burr, 1/8-inch head single cut, for its spherical tip to hollow mounting holes without flat bottoms, preventing stress risers in high vibration zones. Verbal steps: measure the bracket blank against the frame tube, e.g., 1-inch diameter, marking hole centers with a center punch. At 11,000 RPM, ramp the Burr into the material with helical entry, 0.01-inch depth, orbiting to enlarge to 0.75 inches while maintaining 2 mm walls, cooling with mist to avoid alpha-beta phase changes that embrittle the alloy. For aluminum, a tree-shaped Burr tapers slots for adjustable angles, its pointed end accessing ends without binding. This mod shaves 50 grams off stock weights, improving handling. Conceptual diagram: a top-down view of a bike bracket, stock as a flat plate with circular hole. The ball-nosed Burr orbits inward, expanding to an oval slot, shaded removal zones, with torque vectors showing reduced stress, pre-100 Nm peaks, post-70 Nm, and a mounted light icon illustrating the customized fit for night rides. In bicycle and motorcycle customization, Carbide Burrs facilitate techniques like handlebar shaping and frame deburring with selections tailored to lightweight materials, flame for aluminum contours, diamond-coated for carbon, narrated through step-by-step mods that enhance performance and style. Conceptual bike diagrams visualize the transformations, from swept bars to smooth welds, empowering builders to craft rides that reflect personal vision while optimizing for speed, comfort, and durability on the road.